In this algebra video, we're in Chapter 4, Lesson 4. We're going to talk about parallel and perpendicular lines, but more specifically, we're going to talk about the linear equations of parallel and perpendicular lines. And of course, we'll define those in just a minute. Our objective is, as the student, I can write an equation of the line that passes through a given point that is either parallel or perpendicular to a given line. And on that note, you don't have to write this right now, we'll get to it. All the instructions for your questions are going to say something along the lines of this. Write an equation in slope-intercept form for the line that passes through the given points and is, either it'll say parallel or perpendicular, to the graph of the given equation. That's basically what we're going to do for each of these questions. So in each of them, we're going to have a given equation. And the instructions are going to say, either write a parallel equation or write a perpendicular equation. Well, if it says parallel equation, we'll talk about what that means in a minute, they're going to give us a given point. So we're going to use some skills we're about to now cover of how to do this. But every question is going to start the same way. We're still going to use point-slope form in order to set these up, just like we've been doing. Let's talk about some other stuff. Let's make sure we review and remind ourselves what parallel and perpendicular lines are. Parallel lines, most of those people know. Parallel lines are lines that never, ever, ever touch, cross, or intersect or anything like that. So an example are two sets of lines like that. Now I'm actually going to write those smaller so you can actually have them where they're more useful. So add this to your notes. There are two lines that just never cross. They can be going, if they're straight up and down like this, if they're vertical lines, that means they both have an undefined slope, so that means they're parallel. If they're, I missed, that's supposed to be horizontal. If they are horizontal lines, that's not quite horizontal. Let's pretend they are. Then they both have a slope of 0. They never cross. Oh, maybe I'm starting to give away what I want to say. Essentially, here's what you need to know. You need to know that parallel lines, they have the same slope. That's the big idea. That's the big finisher. That's the skill we're going to use here. So they have the same slope. Meaning, if two lines are going to be parallel, such as our two lines right here, if the slope of one of them is 2 over 3, then that means the slope of the other one has to be 2 over 3. Now, I just made up that 2 over 3, but their slopes will be the same. Hold on to that thought. We're going to use that. Now let's talk about perpendicular lines. Perpendicular lines are lines that touch or cross or intersect at a right angle. In other words, 90 degrees. Such as these two lines. They cross at a 90-degree angle. Where they cross will be exactly 90 degrees. So now, they're the big finisher. What you need to know about perpendicular lines, this is important. You need to know that their slopes are opposite reciprocals. So you want to know their slopes are opposite reciprocals of each other. Now, of course, I'm going to show you some examples of that. So, to be specific, if the slope of one of the lines is, I don't know, let's say 2 over 3, then the slope of the line that's perpendicular to that line is the opposite reciprocal. Okay, well, opposite means change the sign. So if it's going to be positive now because there's nothing in front of it, the opposite of that is going to be negative. So this is going to go and turn into a negative. That's an arrow, by the way. Now, reciprocal. Remember, reciprocal means flip it. So you're going to flip your fraction, which becomes 3 over 2. So there we go. If the slope of one of them is positive 2 over 3, its opposite reciprocal, meaning the slope of of a perpendicular line, is going to be negative 3 over 2. So positive 2 over 3 becomes negative 3 over 2. Now, we can also do this with whole numbers. Let's say we had negative 4. Let's say the slope of one of our lines was negative 4. Now, that means the slope of its reciprocal is the opposite. Well, it's negative, so it's going to become positive. Remember, 4 is technically over 1. So when you flip that, it's 1 over 4. And it's positive 1 over 4 because that's the opposite of negative 4. So there you go. The opposite reciprocal of a slope such as negative 4 is positive 1 over 4. If this had already been a positive 4, then this would have become a negative 1 over 4 if that had already been positive. So this is what I mean when I say opposite reciprocals. You're going to need this information. Write it down. Think about it, because this is how you're going to start every question with the same basic steps. What is our slope? What is our point? Okay, let's use point-slope form. That's what we're going to do. But we're going to make sure we understand how to identify our slope first. So our first skill is how to identify the slope for ourselves. So draw this table, draw this format. We're going to do a couple examples to make sure you understand how to identify their slope, our slope. Okay, so let's say their equation was y equals 2/5 x plus 2. Now notice, I already wrote it in green for you to show you the slope is the number in front of x. It's always the number in front of x when it's in slope-intercept form. You know it's in slope-intercept form because y is by itself. Remember, slope-intercept form, by the way, is y equals mx plus b, meaning y is by itself. Okay, so if their slope is 2/5 and we're looking for our parallel slope, well, we just got done saying parallel slopes have the same slope. So if their slope is 2/5 and we're going to be a parallel line, that means our slope is also 2/5. That's what that means. Now let's say our question said we need to be perpendicular. Well, if their slope was 2/5, then our slope is, think about it, opposite reciprocal is what we said. Take a moment to think. All right, we're going to be negative 5/2 if it said perpendicular. So that's an example of what I mean. When you look at their equation, we don't care about this +2. You can ignore that +2. All that matters is the slope, the thing in front of x. That's all we need their equation for, because we're just trying to figure out what is their slope. Because remember, our instructions are write an equation in slope-intercept form for, here's the important part, the line that passes through the given point, meaning in our questions we'll be given a point, but now here's what it says, it'll either be parallel or perpendicular to the graph of the given equation. So in other words, the given equation for this case was y equals 2/5 x plus 2. All we needed was a 2/5. We need to know their slope. Let's try another one. Let's say we had y equals negative x plus 5. Well, we got to find out what their slope is first before we even know what ours is. Their slope. Well, the number in front of x is, there is no number in front of x. So remember, there's an understood 1 out there. Now, if there's a negative sign, that means it's -1. Now, if there was nothing out there, we would have said +1. So that means their slope is -1. Okay, so if we're going to be parallel, we're going to be the same slope. So if we're going to be parallel, we're also -1. I meant to do that in blue. Now, Now, if we're going to be perpendicular, we're the opposite reciprocal. We'll take a moment to think about that. -1 is technically over 1. The opposite reciprocal, well, if you flip it, you're still going to have 1/1. Okay, so it's still going to be 1, but it's going to be the opposite. Well, the opposite of -1 is +1. So, okay, the opposite reciprocal of -1 is just +1. Technically, it's 1/1, but for the sake of space and also knowing it's the same thing, I'm just going to write +1. It means the same thing. Alright, so we've done some examples of how to find our slope if we know their slope. Now, let's take a look at what's going to happen. Notice, in each of these examples I gave you so far, the given equation, their equation, was in slope-intercept form. It's really easy to tell slope when it's in slope-intercept form. But what happens when it's not in slope-intercept form? What happens when it's in standard form? What if their equation was given to you in standard form? What if they said, okay, you gotta do the same instructions I gave you before, same instructions as here, but now their given equation isn't in slope-intercept form, so we don't know their slope yet. So here's what I'm going to show you. Yes, there's a way to find it, and so that's what we're now take a moment to skip some space to continue this table. We'll do 2 examples of standard form, but let's take a note real fast on how to find the slope of standard form. So now remember, standard form has this format: ax plus by equals c. A is the coefficient of x, b is the coefficient of y, and c is that number all by itself on the other side of the equal sign. A, b, and c, the things in blue, those uppercase letters, they will be actual numbers in your example. So let me write down the one we just had. So the long way, there is a shortcut for this, by the way, but I'm going to show you the long way first so you understand the shortcut. The longer way is, let's put it in slope-intercept form. Let's use our fraction skills to get y by itself. So if we were to do that, go ahead and show your steps. You would move positive 9x to the other side by minusing 9x on both sides. So notice, on the right side, it's negative 9x. So we have 3y equals negative 9x plus 8. Now finish getting y by itself by dividing both sides by 3. I'm going to use a fraction bar since we've got all the right side divided by 3. So if we do that, on the left side, we're left with just y. And on the right side, we've got negative 9 divided by 3. That's going to give us our slope. Well, a negative divided by positive is a negative. Okay, so negative 9 divided by 3, well, that's negative 3. So we have negative 3x, and now 8 divided by 3. That's going to be our y-intercept. Well, 8 divided by 3, well, that's 2 and 2/8. 2/3 positive, so 2 and 2/3. Now, you could leave that as improper if you really wanted to, but I like to see y-intercepts. But honestly, it doesn't even matter. I don't even know I'm talking about the y-intercept. That we don't care about. The truth is, all we needed to know is what is their slope. And notice, now that we have it in slope-intercept form, we know what their slope is. Their slope is -3. So this was the long way of doing it. And now I'm gonna show you that with the literal equation real fast. I'm gonna go through those same steps with just the letters to give you an overall format, and then I'm gonna show you the shortcut. So those same steps with the standard form will look like this. And if you do that, you'll be left with this: y equals negative a over bx plus c over b. But what's important is take a look. We know that slope is y equals mx plus b, meaning m is the slope, the number in front of x. Well, take a look. The slope is negative a over b. So that's actually our shortcut. Our shortcut is, for standard form, the slope will always be the opposite of a divided by b. Because look what we have. We have the opposite of a divided by b. And when we say that, when it start off with standard form, so the opposite of a divided by b. So let's see if that fits our thing over here. The opposite of a. Well, a is 9. So the opposite of a is negative 9. Okay, so the opposite of a divided by b. Well, b is 3. Okay, so negative 9 divided by 3. All right, so negative 9 divided by 3, well, that's negative 3. That's the slope. Well, hey, that's what we just said the first time around doing it the long way. So this shortcut is your friend. You want to use this when finding the slope of standard form. But honestly, it's not mandatory. You're welcome to do it the long way, because this way is the way we already know. To find it, I was just trying to show you steps. So here we did an example with numbers, we did an example with the letters, and then we discovered our shortcut when we did it with letters, meaning the literal equation skills we learned back in chapter such and such, I think it was 2, that stuff is paying off. Actually, I think it was one of those chapters. So no matter how we did this one, we still end up with a slope of negative 3. I think you'll agree the shortcut is your best friend. So that's what I want you to have. I want to make sure, have all of this, if great, but I want to make sure you have the shortcut. This is the meat of what we're doing when finding the slope of standard form. It saves you a lot of time. Okay, so that means if their slope was negative 3, I'm going to just squeeze that in there. If their slope was negative 3, if we're going to be parallel, our slope is going to be negative 3. If we're going to be perpendicular, we're the opposite reciprocal slope of that. So that means we're going to be positive 1 over 3. So that would be our slope if this was a perpendicular question. All right, we'll do one more standard form one, and then we're going to move on. Let's say their equation was 5x minus 6y equals 9. Okay, so I definitely would recommend we use the shortcut. Remember, it's opposite of a divided by b. Okay, well, opposite of a is 5. So now the opposite of 5 is negative 5. So it's going to start off with a negative 5 over b. Well, b is not just 6. B is negative 6. Okay, so b is negative 6. So negative 5 over negative 6. That is the slope. However, you'll notice we have double negatives. And you got to remember, what is a negative divided by a negative? Well, a negative divided by a negative is a positive. So this is really positive 5 over 6. So that means their slope is positive 5 over 6. All right, so if we're parallel to that, our slope will also be positive 5 over 6. Now, if we're going to be perpendicular to that, we're the opposite reciprocal. Take a moment to think about that. Hit pause if you need to. The opposite reciprocal of that is opposite, make it negative. Reciprocal, meaning flip it, so it becomes 6 over 5. That's our slope if we're going to be perpendicular. All right, so I want to emphasize this skill because this was the thing that was tripping up a lot of students. This is the only new skill in this section, meaning how to make sure we can identify what their slope is, and especially when it's standard form. This is new to us. We hadn't talked about that before. And then what we're now going to do is we're going to do a bunch of examples of these, well, maybe not a bunch, but several, where we're going to be given a point, and the point will be given. We'll figure out their slope, and then based on what the question's asking for, whether parallel or perpendicular, we'll be able to figure out what our slope is. So once we have our point, and then we know our slope, we're ready to go. Alright, so each of the instructions are going to be like this. And here's what we're going to do. For our examples, we're going to pretend it was both. For all of our questions, we're going to treat it as if it was a parallel question, and we're also going to treat it as if it was a perpendicular question. So we're going to do each of these examples times 2, but just for each situation. That way you're prepared and you're getting the double the examples at the same time. Alright, so the question is going to say, hey, write the equation of our line that passes through this given point and is parallel to this given equation. And another one where it's perpendicular to this given equation. That's what we're going to do. So I'm going to move this to another page where we have more room, and we're going to set this up side by side. Alright, so before we jump into this, I want to give you a reminder. We're about to use the skills overall, what we've always done. But before we do anything, we're going to go ahead and find the slopes that we need. We're going to do an example where we're parallel, and we're going to do an example where we are perpendicular. So let's start by doing what we just practiced. How to find the slope, how to find their slope to help us find our slope. So, since theirs is already in slope-intercept form, our life is easy. We just got to look at m. their slope is 1 over 2. So if their slope is 1 over 2, we now can use that to help us. If we are going to solve this equation as if we are parallel, that means we have the same slope. So if we're parallel, that means our slope is also going to be 1 over 2 for this example. So we're going to be using the slope 1 over 2 and then the point -4 comma 3. Let's say instead we're going to be perpendicular. So if their slope is 1 over 2, our slope is going to be the opposite reciprocal. So we're going to be -2 over 1. Well, -2 over 1 is just -2. So our slope is going to be -2 if we're talking perpendicular. So now before we go any further, we now have a slope and a point. A slope and a point. So we know how to do these questions. So as a brief crash course, what we're going to do is we're going to use point-slope form. We now know our slope. We just did that. We didn't need the slope formula. By the way, I copy and pasted this straight from one of your past videos. You don't need to necessarily write this down. We have our slope. We have our point. Now we're just going to plug it into point-slope form and turn it to slope-intercept form. So a reminder of those steps to go from point-slope form to slope-intercept form. In general, this is review. I straight copy and paste this. You don't necessarily need to write this down. This is from one of your past videos and notes. You should have those to help. And now an example of doing that, this isn't our problem, but this was just an example of numbers of turning point-slope form into slope-intercept form. This is basically what we're going to do. So that was your crash course reminder. Look at those notes to help you. Everything builds on. All right, so let's do it. Let's set this up in a point-slope form. So I'm going to write the shell for both of them to get it ready. So I got the shell for both of them ready. So now we're just going to plug them in. I'll plug in the easy stuff first. I'll plug in the slope. Remember, so for the parallel example, our slope is 1 over 2. For the perpendicular example, our slope is -2 for the reasons we already said. Now we're just going to plug in the x and y values from our given point. So the y values, the x value goes inside of here. So it's x minus -4. We got to remember how to minus a negative. That means you add. So this is x plus 4 in there. Same thing is going to happen over here as well. So that's x plus 4. Now let's plug in the y value. Y minus 3, y minus 3. There we go. We've now set both of these up. Now go through the same steps using the same skills. I'm not going to super explain it, but I at least want to show you how to set it up. Now I'm going to show you the steps. Hit pause and try them if you think you can already do it. So for the parallel example, the equation of the line that is parallel to the given equation that passes through this slope, well, the equation of that line is right here. Y equals half x plus 5. Now let's do the perpendicular one. Hit pause and do that one if you haven't done so already. If the question and instructions said write the perpendicular line, this would have been our final answer that we would have gotten. So we did pretty much 2 examples at once of writing each of these. Now you're going to try some. So you try this one. Alright, so you hit pause and give these a shot. You treat it as if this was 2 separate questions. Write one equation where it's parallel to theirs, and write one equation where it's perpendicular to theirs. But make sure you find the slope first. Hit pause and give these a shot. Alright, so we got to start by making sure we know what their slope is. Well, when it's in slope-intercept form, to identify their slope is easy. Their slope is 2 over 5. So if we're going to be parallel, we're going to have the exact same slope. So if we're going to be parallel, our slope is going to be 2 over 5. But if we're going to be perpendicular, our slope is the opposite reciprocal. The opposite reciprocal of that is -5 over 2. That's supposed to be a 2 down there. Okay. So now we know our slopes. Now see if that was the hint you needed, if you still need more help. Or if you were stuck up until now. Now try. Alright, so now we're going to plug these in a point-slope form. They both set up the same way, just different slopes. So remember, they both start with the same shell. So now plug everything in carefully, just like we've practiced before. Okay, now that everything's plugged into point-slope form, if you just need help getting this far and you still need to try it on your own, hit pause and see if you can take it from here. Alright, so both these start off the same way. They both start off by distributing. Now notice, I'm doing both of these side by side on purpose because I want to show you how finding parallel and perpendicular is the same process. The only difference is you start off with a different slope. Simple as that, using the definition of what does it mean to be parallel or perpendicular. Alright, so let's distribute and show our steps. 2/5 times 5, that's a positive times a negative, so it's a negative, so that's why I put the minus sign there. So now 2/5 times 5, well remember that's really 5 over 1, so that's 2 up top times 5 up top. So that's going to give us 10 over 5. Well, 10 over 5 simplifies down to 2. And you could have also said that because if we are multiplying by 5 and then we have divided by 5, multiplied by 5, those are going to cancel. So you're going to be left with 2. So that would have been the faster way. But it doesn't matter. Regardless, show your work however you need to, but it equals -2. Drop that down. Now move the -4 and you're done. Okay, and that's your final answer for the equation of the line that is parallel. Now do the perpendicular one if you haven't done so already. So make sure you realize that this is the answer to this one, that y equals 2/5 x plus 2. Alright, let's get back to the example on the right for perpendicular. Go ahead and distribute. Alright, well the first part's easy, but now distribute the second part. A negative times a negative, that's a positive, so we put a plus sign there. Now we have -5/2 times 5. To make sure we're clear, I'm going to show my work down here, but I'm going to erase it afterwards because I don't have space. But you should do yours off to the side of your paper or somewhere out of the way so you can show your work and then do it. We already know it's going to be a positive, so I'm not going to bother with the negative signs because you know negative times negative is a positive, so I'm just going to worry about the fraction. So that equals 12.5. So plus 12.5. I'm going to leave it as a mixed number. And honestly, I'm leaving it as a mixed number because I'm cheating. I know that I'm going to have to add 4 to both sides. So adding 4 to 12.5 is easy. It's going to be 16.5. Sorry, I didn't mean to jump ahead. So now I'm going to erase my work down here to get that out of the way. Actually, I think I can get away if I move it all the way to the bottom out of the way. I think there'll be room for me to finish showing the steps and finishing from there. So drop everything down. Let's finish. Now move the -4 and you're done. Notice the slope was an improper fraction. Remember, we leave slope as improper fractions. We do not change that to a mixed number. 12.5 plus 4.5, that's 16.5. So that's where that came from. So we're done. That's our final answer. This is the equation of the line that is perpendicular to the given line and passes through the given point. Great job, guys. Alright, so you give this one a shot. Hit pause and try this one. And just remember the hint I gave you about how to find the slope of standard form. So go back to that part of your notes, which was right here, how to find the slope of standard form. So you're going to use that to help you with this question. So hit pause and give it a shot. Alright, so by the way, this is going to be our last example doing these two, and then we'll be all done. So we got to start by finding their slope. Well, we're going to use the shortcut because that shortcut is your best friend. And remember, that shortcut was, the slope was the opposite of A over B. So let's do that. Well, A is 5. So the opposite of 5 is -5. Okay, so we have -5 over B. Well, B is -4. So we have -5 over -4. Okay, well, -5 over -4. That's a negative divided by a negative. Well, that's a positive. So that means their slope is +5 over 4. That's the slope of their line. Now we know the slope of their line, we can find out the slope of our lines. If we're going to be parallel, our slope is going to be the same. So if, for our parallel example, we're also going to be 5 over 4. But if we're going to be perpendicular, remember, we're going to be opposite reciprocal slopes. So the opposite is -4 over 5. So if we're being the reciprocal, we're going to be -4 over 5. So here we go. We've got our slope. We've got our point. Now we just need to put them both in the point slope form, get that shell going, and you're ready to go. I think you can take it from here if you haven't done so already. Alright, get that shell going. I'll plug everything in. Uh-oh, when you go to plug in that x, it's -8, so make sure you change that to +8. Alright, now that we've got them both set up, you should be able to take it from here. Hit pause if you haven't done so already and turn these into slope-intercept form. A positive times a positive is a positive, so plus. Now you just got to figure out what is 5/4 times 8. 5/4 times 8. Shortcut it up. Alright, and it equals 10. Okay, so that's going to equals plus 10 right there. Alright, drop everything down. Now finish getting y by itself. I'm going to move that down out of the way first, so preferably out of the way as much as possible. Okay, and this is our final answer of our equation that is parallel to the given equation and passes through the given slope. That kind of looks like a fish. A Swedish fish. But that's off topic. Now, remember, this fraction stuff, I don't like putting it down below like that. I would normally put it off to the side, but I wanted you to at least have it, to see where it came from. All of this is what told us where that 10 came from. That's what this was for. Alright, now finish the other one if you haven't done so already. The first distributing part is easy. The second one, a negative times a positive, well, that's a negative. Now you just need to figure out what is 4/5 times x. Well, the good news is, we know what 5/4 times, I said x, I meant 8. So we're going to do 4/5 times 8. go ahead and turn that into a mixed number. And I say that again because we're going to end up adding 2 to it, and it's easier to add when it's already a mixed number because then you just add the whole number. And you get 6 2/5. Alright, so now drop everything down and then get rid of that minus 2. We're going to move our fraction work out of the way a little bit more so we can have room to write our final answer. And the beauty of this is our final answer when we do this is going to be y equals negative 4/5 x. But because we do not cross 0, by the way, I was taking the shortcut. I took it over took it in our last one as well. But because we're not crossing 0 here, you don't need to worry about improper fractions, common denominators. None of that matters. Just do it to the whole number. What is negative 6 plus 2? Well, that's negative 4. Oh, still in highlighter mode. So that's negative 4, but it's just going to be in 2/5. So negative 4 and 2/5. That's our final answer. So y equals negative 4/5 x minus 4 2/5. That is the equation of the line that is perpendicular to the given equation and passes through the given point. Alright, so brief recap and we're all done. We did several examples. We did 2, 4, 6. Okay, so we did 6 full examples together. Alright, and then I gave you a bunch of skills leading up to it. Okay, so let's see. We said we can write the equation of lines that are parallel, perpendicular to some given equation and some given point. And we'll say parallel or perpendicular. We then reminded what does it mean to be parallel, and the big idea, the big finish was the definition of parallel as far as slopes are concerned is the two lines will have the same slope. Well, perpendicular, we said they'll have opposite reciprocal slopes. Then we went on to apply that. Did some examples of their equation. What is their slope? Okay, therefore, what is our slope if we're parallel? What is our slope if we're perpendicular? This was a good skill, was to make sure you understood this. And the really new thing you hadn't seen before was how to find the slope the fastest way possible of a standard form equation. And I gave you that shortcut. That shortcut is your best friend as far as finding the slope of standard form, but it's not mandatory. If you don't remember it, it's not the end of the world. You can always get it yourself by putting it into slope-intercept form, and then you can just see that slope yourself. So you can always do it the slightly longer way, but I had to figure the shortcut to save you time. Well, now I showed you every question is going to say something like this. So we did an example, but before we did that, I reminded you how to write equations in slope-intercept form. We put them in point-slope form first, using those notes from that video. Now, I showed you the general steps from that same video, and then I showed you that same example from that same video, and then we went ahead and jumped right into it. We did a slope, did our point, and we turned to slope-intercept form. Every question is just like this, guys. We're applying the definition of parallel slopes and perpendicular slopes. Alright, I hope you have neat, organized notes. I made an effort to give you something very structured, and I agree mine look kind of squished. Please spread yours out more than mine. But good luck, take your time, show your work, be careful with distributing, and you're ready to go. Take care, guys.